Okay, thanks for coming to PhotoTech. This is day 12. We said we'd do 12 or more lectures. Today's our first outside lecturer, and without further ado, I give you Greg Ward from Any Here Software.
Thanks. Oh, applause. I apologize for looking like a drowned rat. I made the mistake of taking my motorcycle this morning, so it looks like I can't hold my orange juice. My rain pants leaked. So I'm going to talk to you about some software that I've developed since working at Shutterfly. So started working on this about 2000 and gradually have plugged away at it. It's an image browser that allows you to take and manage high dynamic range photographs. So it's going to be mostly a demo. If I can get the slides to move. So my motivation at the time was the existing browsers were either file browsers or they were cataloging tools, and there wasn't any one that would do both well. Generally, the file browsers were snappy, and the cataloging tools were painful. And I wanted something that was snappy and would also catalog my images. And none of the existing browsers had any support for HDR. I think that's changed somewhat. And then I didn't like the way the browsers were set out. So my goals were to be able to browse high dynamic range images and maintain catalog information, and also track image files as opposed to storing them in my own data structure. So I wanted my own database of where the files were, and then I wanted to be able to find them wherever they got put. So things that I have achieved so far is I do have fairly fast interactive response, and you can access the thumbnails to images even if the images are not currently accessible. And then you can build, do the usual things with building photo albums and web pages and drag and drop and so on. So things I haven't quite gotten to yet, plug-in interface for photo printing. I mean, that was one of the initial motivations. We wanted to have a decent client tool, but there was no money to develop one. And I haven't gotten to Linux or Windows versions currently. I only have a Mac version, but I'm talking this afternoon with the person who's supposedly working on the PC port. And then I'd like to support more image formats. So the basic browser layout is shown here, and the user interface looks immature because I'm a pretty immature GUI programmer. But the concepts are clear enough. You have a tabs for selecting different ways of searching the data, and then you have just a well with your thumbnails in it. And each time you double click on one of these guys, it starts a database search. And my catalog has 20,000 odd images in it, and the database search takes a fraction of a second, like 1/10 of a second. And then you have the image viewer window, which allows you to do the usual things of zooming in, but it has additional facilities for controlling tone mapping on a high dynamic range image, which we'll play with. And then you can also do some database operations within the viewer window. There's an additional info window that allows you to access other database fields, either allowing you to modify them, in some cases they're read-only fields. The basic architecture of the system is you have a user interface, or you have the program that talks or creates a thumbnail cache, various catalogs, and there's of course a preferences file, and then you have just your images wherever they are on the file system, and you can have them on multiple file systems. I have an external drive, I have DVDs, I have my laptop drive, and I'm always like kicking images off my laptop drive when I'm running out of space. It's a chronic problem with disk space on laptops. So the architecture of the browser is divided into the system-specific GUI layer and the system-independent library, and underlying the system-independent library is this memory cache manager, and this is what's critical to maintaining speed, because images, of course, are large, and you don't want to be reading them in all the time, nor do you want to keep them in memory all the time, so you have to have some intelligent way to deal with memory. And so I essentially wrote my own. It's not a virtual memory system, but it helps the VM system do a better job. And then there's the database manager, which is tied closely to the thumbnail manager, and there's this whole 2D imaging library that handles floating point as well as other image types. And that's a plug-in interface. So with that brief intro, I'm going to talk a bit about high dynamic range photography. How do you capture these images? What can you do with them, and so on. Most mid-priced digital cameras, well, even the low end these days, have an exposure bracketing mode, and the header information, of course, contains the exposure information, which you can use to combine the images to get a single high dynamic range image from the multiple exposures. And you need to do this properly. You need to compute or estimate the camera response function. You're not going to get it exactly, but you can get some reasonable estimate to undo the tone curve in the camera, so you can combine the images properly. And I don't use I don't use the Devevic and Malik technique, but they were the ones who popularized it, and there are actually earlier techniques. But I use the one by Mitsunaga and Nair, which is a polynomial fit. And there are quite a few techniques, and they're all pretty competitive. The real trick is image registration, because most of my pictures are handheld, and then I've added options to reduce lens flare and ghosting. So I'll do this in a minute. So again, the concept is that you take multiple exposures and you recombine them into a single high dynamic range image. And what I'm showing here on this graph is the estimated camera response function, which is this curve. It resembles a gamma curve, but it doesn't exactly fit a gamma curve, because actually, as many of you know, camera makers like to give their images a little more punch, a little more saturation and higher contrast. And so this curve doesn't exactly follow a gamma curve, but if you apply a gamma curve to it, you put this up on a standard display, you'll get an image with boosted color and contrast. So in order to linearize the color space, you really have to figure out what this curve is for your particular camera. And then the other curve shown here, which is a hat function specifically, I call it the Stetson hat function because that's what it looks like, just figures out a weight to use for each pixel. So here are pixel values from 0 to 255 down here. This tells you what weight to give each of those pixel values according to how accurate you expect them to be. So obviously the ones near black are going to be pretty noisy. You don't really want those. And then this weird shape is based on the differential between quantized values and how accurate they are based on the quantization steps. And then you of course have to drop it off at the high end again, because saturated pixels are less reliable. So this shows an example response function. This is a log-log plot where we have the image value down here and the scene value over here. And if you take a gamma 2-2 curve, that's actually a straight line on a log-log plot. That would be this line. So if the cameras really did match a standard sRGB color space, then your points should all lie along this line. In fact, they don't. As you see here, we have this boosted contrast going on. And here's the polynomial fit in red that the Mitsunaga-Nair technique came to. So how do we do HDR capture in Photosphere? Like I said, you can take bracketed exposures such as these, and then Photosphere will align the images if necessary. And there's options for doing ghost removal and lens flare removal, which I'll show you. So the image registration is important because even if the camera's on a tripod, unless you have a tether, there's going to be a little bit of shake, a little bit of movement just from touching the camera. So I came up with this technique after trying a number and failing of using the median threshold bitmap, which is shown here. So here we have two exposures. They're at very different levels, obviously. So if you create an edge map out of each of these, even if you're careful, you end up with a very different set of edges. So matching these two up and trying to align them, you could do it visually, but you can't really do it easily with an algorithm. So using the median threshold bitmap, the median value in a scene, as long as you're looking at roughly the same scene, doesn't change much. And so by using the median as the threshold, you can generate bitmaps that are very similar even for quite different exposures. And then we use a pyramid scheme to arrive at the actual alignment. So you start with a very low resolution version of this bitmap. You line those just by going, you know, a pixel or two left, right, and rotating. And then you work on your way on up the pyramid. And this is quite fast. So alignment results, here we have the original unaligned exposures, which are shown in this blow-up detail. You can see they're off by a few pixels anyway. And then here's the aligned version. And the alignment algorithm gets within half a pixel, but I don't subsample. Yes?
Is that pure rigid alignment?
Yeah, it's rigid rotation. There's no warping involved.
Do you do any kind of radial distortion correction first to make it
That's
aligned?
not necessary. I mean, generally the motions we're talking about are a few pixels. So in terms of distortion and other things going on, it's not that important.
Have you tried to do larger displacements, like maybe handheld? Or, you know,
This is handheld. A lot of these are
Oh, that is-
handheld.
But then they're not going to be within a pixel or two. I mean, you can be off by 20 or 50 pixels.
Yeah, and the alignment algorithm will work up to about that. But it depends on the resolution of your camera too, as to, you know, how far it'll go. But the failures that I've had with this algorithm haven't had to do with too much motion. They've had to do with uneven motion, like waves coming in and clouds going another way. So it tries to do it globally, and if things are moving in different directions globally, it will get confused. And other scenes like waving grass, you know, it's just too much stuff going on, and it can't figure it out.
Do you think this would work for situations where there's parallax? Maybe you're not taking the exact same, you might move the camera a little bit.
No, parallax is a whole other kind of problem. But I mean, in the time that it takes to capture one of these sequences, I mean, I brought this little Olympus camera, but my Nikon will shoot through 9 exposures in under 2 seconds. So you'd have to be on a fast-moving train to even get much parallax in that time. Hey, Lance?
I'm curious about the ghost removal, but I guess you wouldn't.
Okay, I'm going to talk about that next. So ghost removal is another problem. Of course, you can't keep the scene static every time, so people might be moving, trees might be blowing around, and what happens is you get this sort of an effect where your multiple exposures, when you merge them together with that weighting function, you get different positions for the things that are moving. So I developed a simple algorithm was based on a suggestion someone made that if you just pick particular exposures, you know, for those regions, it actually works out. So here we can see, you know, this exposure or this exposure even would have been fine, but it's just the combining of all of them that causes this sort of ghosting effect. And we do want to combine it for other regions that aren't moving, but we'd like to somehow identify these regions with motion and treat them differently. So that's easy enough to do. You can just compute the variance between exposures pretty easily, and identify areas that have high variance, high change between exposures. And then you need to segment those regions because as you can imagine, you need to pick out regions and then choose an exposure to go with that region. You don't want the regions to be too large. You don't want them to cover the whole image because then you're not going to get one exposure that fits the whole region. So you want them to be compact, but you also want them to be disjoint. So this is just a coloring of the different segments that it came up with. And some of these segments that it came up with aren't really in motion, but they were over threshold for the variance because of fringing in the lens and so on. So this is the combined result. And you can see we sort of like lost a bit of this guy's foot. It got faded out here, and parts of the people are still a little bit ghosty, but it's way better than it was. Is there any questions about that?
Did you look at doing any of the combinatorics, like pair-to-pair variance calculations, just so that you could at least get some cumulative depth? Get back to kind of the motion. If you just get one person walking through, if you do the variance over the entire 2-second line sequence, you would have a big smear. But pair by pair, you would have a much smaller space.
Oh, I think I see what you're saying.
And then you might be able to stack those up separately and just get some additional.
No, that would be interesting to try. I didn't think of that. Yeah.
This isn't the same solution as was shown in the other slide, where the chosen exposure is seen dim. The new characters that replace the smear seem too dark. They don't go in place.
So, looking at the final image, the one that we chose is where this guy's right next to the sign for that big purple segment.
Yeah, go back further.
So he was right next to the sign in like the lightest exposure. So I think we chose from this one for that region, and you base it on, you know, what didn't max out the exposure in that region.
But then you bring it
Could
down.
you say a word about the solution in the slide that introduced roasted Google? It's a few slides before that.
Oh,
There.
this one?
Yeah. Those figures look too dark to me.
Oh, well, part of it is just tone mapping.
Well, sure, but you're choosing them from one of the dim exposures. And then when you composite them in, it looks like they need brightening. I don't know.
Well, they are in the darker part of the scene. This is the backlit scene.
So they're from the middle exposure in that sequence.
This one? I don't remember. It was so long ago that I created this slide.
Right, but anyways, I think the best solution that you give later is much better than this one.
Yeah, it could have been an early version of the algorithm. So, yeah. He's not in here twice. That sometimes happens. The person will end up in there twice if they move from light to dark or reverse. They could end up in there twice. So another problem with especially the less expensive cameras is they were never meant to capture high dynamic range, and so the lens design is such that there's a fair amount of flare that they just don't control. And so you get scattering both on the optics, but primarily on the actual aperture. There's scattering on the edge of the aperture. Good cameras have good lenses have very carefully designed aperture vanes. So I took this camera, or one just like it, and took a pinhole in a piece of aluminum foil and photographed it to see what the flare actually was. So this should be a perfect circle if it were a perfect lens, but as you can see, there's quite a bit of energy that is exposing the sensor around that position. So from this image, you could actually derive what the point spread function is and correct for it. I mean, you could just also go into Photoshop and make a circle of the right size and say, I'm done. But you don't get this kind of image to work with. What you typically get is this kind of an image where someone is just taking a photograph. And you could say, well, can't you calibrate the lens and figure out what the point spread function is and just correct for that? Well, unfortunately, the point spread function changes with humidity, changes with aperture, changes with all, you know, everything that touches or changes the lens, zoom, anything, changes the point spread function.
Probably changes with the position in the image as well.
It does, a little bit. But we kind of ignore that in our solution because we don't have enough information to characterize the point spread function as it changes over the image. But what we can do with an image like this is look for dark areas, dark regions around bright regions, and estimate the point spread function using a RMS kind of, you know, a mean squared kind of approach. And doing that, we took, again, it was this camera, and those previous two images, the flare image and this image, were taken with the exact same settings, like shortly after each other, so hopefully nothing changed on the lens. And then we measured the point spread function from the pinhole, and that's shown on this red dashed line. And then this is the point spread function that we estimated based on our algorithm applied to the image of the apartment. And they're not a perfect match, but we wouldn't really expect them to be, because the point spread function estimated from the apartment image was averaged over the whole image, whereas the point spread function for the pinhole was measured at the center, and that's going to be the best case. So we would expect a little more spread when you averaged over the whole image. And then we can undo that. And here's an example where we've undone the point spread function in this image of Rosetta stained glass, and this is the corrected version, and this is basically the flare, lens flare that was removed from this corrected version. My SLR camera doesn't have this problem. I almost never need lens flare removal because the lenses are much better, yeah?
Yeah, but SLRs often have major ghosting problems. How do you get rid of lens ghosts?
I have no algorithm to, I think you're talking about sundogs where you have like a bright flare source and it's causing into reflections that shows multiple color kind of. No.
If you have anything bright in the image, you get a second image of it rotated 180 degrees around the center of the frame.
Different cameras will do different things here depending on the objects.
It depends on the lenses. The better the lens, the worse the problem is to be.
No, I haven't worked at anything more complicated than this. I mean, yeah, like Dick says, different lenses will do different peculiar things. And it's kind of hard to come up with an algorithm that will just generally recognize what doesn't belong in the image and remove it.
It's always consistent. It's always a second image 180 degrees around the center of the frame.
If it's always that, you could easily subtract it, estimate it and subtract it.
So why do you mean that would it make sense to deconvolute it rather than subtract visions? It's actually spreading that function to get back to more original information and get it accurate.
Try repeating the questions too.
Oh, he was asking if it wouldn't make more sense to apply a deconvolve once you know the point spread function, just to put the energy back where it came from. I think that would make sense if it were much energy, but it's not much energy. It's only a tiny fraction of a percent that gets spread, but because it started so bright, it becomes apparent, and that's why it only shows up really on the HDR. It's only really objectionable on the HDR. See, if we showed this as a linear tone mapping, you'd basically be looking at little white spots surrounded by black. But we've tone mapped it to, and that crushes the contrast range, so you start to see these things that you wouldn't see otherwise. But you'd also see them on a high dynamic range display. So, okay, so now let me do a little demo. This works. So currently, Photosphere is just being distributed as unadvertised freeware. We also have a command line version that runs under Linux as well as OS 10. And as I said, my friend is working on a multi-platform port. Okay, so I think I'm going to have a little issue with my screen. Huh. So it looks like PowerPoint was trying to be clever and throwing it into mirror mode, which kind of worked. Never done this before. It's interesting. New version of PowerPoint, new fancy features. So let me start with a quick demo and try taking a series of bracketed exposures just to show you how easy it is, assuming it works. Okay, so this is, when I bought this camera, it was like $400, but now you can get these particular ones on eBay for under $200. I like it better than the newer cameras because the newer cameras just have higher noise, tinier pixels with worse lenses. So besides this, I have an SLR, as I mentioned, which I'm quite happy with. So I first choose the mode, and I have to make sure that it's in a bracketed mode. I wish I had a way to display this. But basically, I'm just choosing 5 exposure brackets separated by 1 f-stop, and then I also have to make sure that the white balance is fixed, because if you use an automatic white balance, at least on this camera, it will change the white balance from one exposure to the next, which just wreaks havoc on the whole algorithm. And I've heard that the newer cameras do even worse than this. They also change their tone map curve per exposure, which is a disaster.
Shooting RAW or JPEG?
I'm shooting JPEG, and you can shoot RAW on some cameras, but Photosphere doesn't handle RAW, and it doesn't actually benefit the results much. I mean, the main advantage of RAW is that you're in a better known color space, and you can just say.
I just wondered if it was possible to do the image stacking prior to doing the Bayer
People have done that. In fact, I saw a poster or two. Yeah, a poster or two on that. Well, the thing is, if it's handheld, it's not perfectly aligned. So you'd have to be really clever about how you did the automatic alignment and how you did the demosaicing afterwards, because once you've entangled those two, it's a bit of work. So I'm just going to take a couple of HDR shots. So people hold still. Let's see. The other thing that I have to fix is the aperture. So, not the fastest camera in the world. It's a wonderful little camera, but you can't get the smart media cards anymore. I stopped making them. All right, so. Yeah. I used to get compact flash and smart media confused, and then I realized that it's easy to remember because the compact flash are the big bulky ones that have some intelligence built in, and the smart media are the compact ones with no intelligence.
Could I ask you a question?
Yeah.
Along the lines of the last question, so if you did something like this technique, but same exposure, just multiple, rapid fire exposures, could you take advantage of the jitter to sort of get
Super resolution.
deal with the Bayer, sort of eliminate Bayer and wind up with a Foveon light camera?
Possibly.
What do you think? Exception to that.
You need things to be really, really still for that
Well,
to
I know
work.
you actually want a pixel or two of jitter for that, right? Because then your green would move into your reds.
No, you want to know where things are.
Well, you have to align it.
So
Greens could move into your greens.
I have a bunch of options for removing ghosts. I'm not going to do any of the options right now. I'm just going to have it combine the images to show you what it looks like without any fancy stuff.
What's the use safe response?
Oh, some exposure sequences are better than others for deriving the camera response. You're better off with like big smooth areas and a fairly wide dynamic range scene. And so the way Photosphere works is it will give you the option the first time you use the camera of saving the response, and then you can reuse the saved response rather than recomputing it each time, which is more less reliable. And the new version of Photoshop, the CS3 beta, does something similar, but it's a little more intelligent about it. Okay, so you can see people moved a little bit. I wasn't holding the camera quite still. So I can try next just doing the image alignment without ghost removal and see what that looks like. Nobody's moving that much, so I don't expect ghost removal to do much, but I'll do the image alignment anyway. So now it has a second pre-pass where it's figuring out the alignment between images. As you can see, it's pretty quick. I think I never turned my mic on. Testing. All right.
It's on.
So that was before. This is with alignment. So you guys are good at holding still. It's all that practice working on your computers, staring for hours. Okay, so I don't think that ghost removal is going to do anything for this. So I'll just leave it like that. And let me do the next sequence. So I took two. And this scene's probably not going to do much as far as flare removal either, so I won't bother with that.
You said you took these pictures one south apart.
Yes.
What's the maximum you can take and still get good results?
I think 3 f-stops. You can even go to 3 f-stops. So the Canon 30D, I think, will take only take 3 exposures. So there, you're better off setting 3 f-stops apart. If you have a scene with a lot of dynamic range, like you're in a forest or something. All right. So there's the second image. So let me pick a point between them. Looks like I didn't get that much overlap, so I'll choose feature over here maybe. So this is my panorama algorithm is kind of clunky the interface to it, you have to basically help it find a feature. You sort of say, the feature's around here, and then it does a little wiggling to actually align the two, or match the two up. And then you can make it into an HDR panorama.
So it's computing the translation and rotation between the two and overlapping using that.
It just, all it does for the feature is it finds a match point, and then it grows a seam from that. So it
So
doesn't,
it basically constrains X and Y, and then you just have to figure out rotation after that.
well, it doesn't do rotation. It actually just assumes they're the right orientation, and it creates a seam by blending the low frequencies and splicing the high frequencies. So if you look at it up close, you can see a little bit of funny wiggling going on as it's trying to get things to line up, and it totally messed up Lance's face there and Dick's shoulder. But for natural scenes, it works really well. For other scenes, not so well.
Great.
Yeah.
If you made it an elastic map, then you could go further. People could move their hands, bunch their eyes, change expression, and you can still get a few things.
Yeah, well, I wanted to get something working quickly, so. I'm not going to save this. I have examples. Switch catalog. Of natural scenes where I've done panoramas. So this is from my recent trip up to Crescent City to visit my brother. So I think this is 3 images. And so there's a splice running along here somewhere. I've even spliced waterfalls, and they work pretty well. This, you can see some schmutz up there. But for the most part, it's hard to find the scenes, and it's because the seam winds its way through. So the high frequencies are spliced, and the low frequencies are blended, and your eye doesn't pick the seam out as well, as easily. So another example. This one is, I think, just 2 images spliced together. But again, it's better on natural scenes than artificial ones, because artificial ones, if you start wiggling straight lines, it really jumps out at you.
Was the reckoning the same in this 3 just shot?
No, they were taken with the Nikon, so that they might have been 7 or 9 exposures going in. And the other thing I wanted to mention is that most of my HDR images I store in this JPEG HDR format, because otherwise they would take up a whole hunk of space. Like this image, as soon as it opens up, is 13,000 by almost 3,000 pixels. So in an HDR format, that would take on the order of, I think, 90 megabytes or more. But with JPEG HDR, this is 4.5 megabytes.
What is JPEG HDR?
JPEG HDR is a format that I developed for Brightside Technologies that if you take the image and just drop it onto a standard viewer that doesn't know about JPEG HDR, such as most viewers these days, you'll get just a low dynamic range, tone-mapped version of the image. So this is what you would see. So this is basically Reinhardt's tone mapping operator applied to that image. But then there's additional information in the JPEG markers that allows you to reconstruct the high dynamic range version. And that additional information takes about 20 to 25% more file space. So it's a chunk of data, but it's not huge.
Can you store that in ETSIT?
No, it's stored in the JPEG marker 11. So the JPEG has, I think, 15 application markers that are used for various things. And so
it's essentially a compressed zil.
it's a compressed ratio image. So it's a JPEG compressed log luminance ratio image. And the other thing that I didn't mention about HDR or about photosphere is that the images actually have physical values in them. So if you go in, it'll tell you the sky is 1,500 candelas per meter squared, and the ground averages 200 candelas per meter squared. And so you can use this for image analysis, photometry, and that sort of thing. The sun.
You derive this from the exit and.
Yeah, and you can calibrate it. I mean, I seriously doubt I captured the full dynamic range of the sun, because it's, well, I'm close. 3 times 10 to the 5th. I think the sun, when it's full up in the sky, is about 10 to the 6th candelas per meter squared. So I might have actually captured the top end of this. You can sometimes tell by looking at the histogram. No, see, it's clipped, so I didn't quite get it. And there's also a false color mode that you can use and you can play with. Anyway, so there's a lot of stuff you can do from a photometric application standpoint. And as far as I know, Photosphere is the only application that makes any attempt at photometry. So any other questions? I'm going to talk about JPEG HDR in a minute. So.
Any other issues with low light photography and sensor noise in terms of your algorithms?
Yes, there are issues with sensor noise, not necessarily related to low light photography, because the cameras have the ability to subtract that, most of them. But there are issues with some CMOS sensors and some noisy sensors if they have like little bits of noise or leakage at a higher level. Sometimes when you combine them, you'll have this really dark exposure that has a not quite black pixel that really should be black, but because of leakage it's not black, and that will show up as a bright spot. If the images are perfectly aligned in all the exposures, it will show up as a bright spot.
I wondered about the variance algorithms and whatnot, whether or not if you had done a nighttime panorama with bright lights in it, whether those dark regions would end up with shot noise variance.
I haven't noticed that. This other problem with sensor leakage is one I'd like to solve, though, but it is one that would really benefit from looking at the raw file, because otherwise it's difficult to identify where those problems are.
Wouldn't combining 5 images average out one of them?
If the images aren't perfectly aligned, yes. But if the images are perfectly aligned and there's one pixel that isn't corrected for, and that's what, I mean, on my Nikon I have a few pixels like that aren't corrected for. This camera, which is a much less expensive camera, has a function to remap the pixels. The Nikon, you have to send it back to the factory and wait 6 weeks. Thank you, Nikon. Okay. So going back to the slides. How are we for time? So as I mentioned, I have this HDR stitching thing, and here I have a quick comparison to competing methods, like the splice, everyone's favorite. Photoshop doesn't, in the CS2 anyway, it doesn't do much more than a splice. It does this crap linear blend, and they have an advanced version that has a really poor implementation, as far as I can tell, of Burton Adelson's algorithm, that looks like this. Well, actually, no, it doesn't look like this. It looks a little worse than this. This is my implementation of Burton Adelson. The problem with it is that you can still see the splice, because even though you're splicing the correct frequencies, you have changes between the images that show up. Yes?
Frank, I implemented and applied Burton Adelson at the same time. That scene was focused. That's not a good implementation. You didn't go all the way down to DC.
I didn't go all the way down to DC? No, I didn't go all the way down to DC, because are you talking about the variance you see from here to there?
And the scene, the visibility of the scene.
Well, the visibility of the scene is actually due to motion in the scene. So you have you have the 5 frequencies, but they're in a slightly offset place because the clouds are moving and the waves are moving.
So you divided this image, which is what resolution?
Well, this is zoomed in. We're seeing the pixels here, I think.
Okay, but only 5 frequency bands?
I don't know. I went down to a pixel level at the top end. So the high frequencies are, because the clouds move, you actually see the break in the high frequencies.
But I'm used to splicing two different people's faces together and having the blend be invisible.
Well, I don't know what to say. Maybe there's something missing in my implementation, but it's better than Photoshop's.
Well, actually, in Photoshop, you don't really see the seam.
Yeah.
I mean, you don't see the years.
Somebody let the filter on.
Well, the blend, what happens in Photoshop is it blends,
Yeah.
and so you lose the high frequencies at the blend.
Here you still see almost a translation.
And in Photosphere, it's not perfect either. I mean, we have this problem with the clouds or the fog rolling in over the hills, and it's in such a different place, it doesn't know what to do here. Up here, it will be doing just be doing blending, and then down here where we have high frequencies, it will do a splice, a high frequency splice as well. And the splice moves around, so it's not as visible. If you look really close, you can spot it. It's not a graph cut. It actually, it's similar to a graph cut, but only in the high frequencies. It also does some pulling. So if the images aren't perfectly aligned, it will sort of like pull them together. Yeah, and that's what happens. It makes the edges look nasty. So I need some hysteresis in there, but I just haven't gotten around to implementing that. So in the future, I sincerely hope that they have high dynamic range cameras so we don't have to do all this nonsense. And it's quite easy to do using CMOS sensor technology or even just reprogramming existing sensors. They have some HDR CMOS sensors, but they're generally pretty low resolution. A big part of it is just an education process, getting the Japanese manufacturers to change their ways, as sort of Dick will agree is really difficult. So we came up with this method for changing the way a CCD scans out to get 2 exposures in one shutter opening. So the old program, they have this electronic shutter that allows you to take a rather crude short exposure, and this is what it uses in video mode. But you can leverage this chip design by taking a short exposure right after your longest exposure. So you clear the sensor, you open the shutter, you have 9/10 of your exposure time go by, you slide those pixels under the electronic shutter, wait the 1/10 remaining, close the mechanical shutter. Then you scan out the longer exposure, shift, scan out the shorter exposure, and you have 2 exposures that are really close together. It's kind of like a slow flash, because you have the short exposure immediately following the long one. So I compared results. I didn't actually implement this because, unfortunately, I don't have access to any cameras with open firmware. But I at least tried a comparison of 5 exposures versus 2 exposures to see the differences. And they're actually not that big difference. And I was really stretching it. I was separating them by 4 f-stops, which is kind of pushing the limit of where you have a good central region. But the results are acceptable. They have slightly higher noise, as you would expect, because you don't get as much exposure averaging, but it works. We just couldn't convince the manufacturer. We got this close to convincing a manufacturer to implement this, but they ended up refusing because they said, well, you have to prove to us that it works. And we're like, well, we need your help to do that. It's like, well, we're not going to help you. Can't prove it. So I have licensed parts of PhotoSphere to Brightside Technologies and also to Adobe. Mostly just the HDR image builder stuff, but Brightside's using all of it. So if anyone's interested. So one of the hindrances to HDR adoption is, of course, file size. Oh, wait, let me remember something here. Kick out my camera before it goes dead. We'll start the show again. Excuse me. So we came up with this idea for, this was work I did with Mary Ann Simmons for Brightside Technologies. She's now at Walt Disney. For, as I explained before, including information to take an ordinary JPEG, or actually a JPEG that contains a tone mapped image, and turn it back into the HDR original. So there's some rationale behind this kind of lossy high dynamic range. Lossy encodings are all about perception, and HDR is also all about perception. There's not much point in recording what the eye can't see, especially if you don't have the space to do it. And we want our lossy HDR to support imagery to the extent the eye is capable of perceiving it. And it's really a requirement for consumer digital cameras as well as web sharing, I think. I mean, I love being able to send people HDR JPEGs as email attachments, which I never could do before. And what if it were backward compatible? So the JPEG HDR encoding is pretty simple. We tone map the HDR input into a output referred 24-bit image, and then we write this out as a standard JPEG segment. And then we have restorative information, basically this ratio image. The naive applications just see the tone map version, and the HDR applications can extract the original. Simple. So the tone mapping operator is not specified. You can actually put a variety of different tone mapping operators according to taste, and they can have local properties or be a global tone curve. Our standard implementation just provides the Reinhardt photographic, global photographic operator, but you can plug in your own just by changing the library calls. So you get this 24-bit image, you divide it into the original HDR image to get your subband ratio image, and they both go through the JPEG compressor to come up with the stored result. So this is what the ratio image looks like for the standard Memorial Church image.
So you don't recompute the subband based on the decompressed JPEG?
We actually do. Yeah, it's a good point. There's a number of things you have to do for error control, like that. So the decoding process, naive application would just use a conventional decompress and get back the tone mapped image. But if you have your HDR application, you also get back the subband, multiply them back together, and get the recovered HDR. And again, there are caveats to how that's done. So the compressed JPEG HDR is about 1 to 7 bits per pixel, depending on settings, which is 1/3 to 1/20th the size of a standard HDR, even with compression.
What do you mean by subband there? Do you mean it's a subsample?
The ratio image. So it's probably a misuse of the term, but it was the idea was derived from NTSC, where it has a subband that's like has the extra information to add color, and it was a misnomer, really.
So, I'm sorry, it's the ratio of what to what?
The ratio of the original image to the tone map version. So we implemented this as an extension of Tom Lane's public JPEG library. This has changed. Brightside's now licensing it for commercial as well as non-commercial use, royalty-free. And it's implemented in PhotoSphere, of course. I think I skipped a slide. No, I didn't. Just flickered. OK, so what about displaying HDR imagery? Well, there's actually a laundry list of technologies that are still in development that might be capable of displaying or are capable, but may or may not ever make it out of the lab, both for projection and conventional desktop. But the one that has made it out of the lab is the one from Brightside. And I have this viewer over there, which I'll show you later. But it's sort of like an early prototype of the idea of having two modulating layers. In this case, they're just transparencies that were generated on a film recorder. But OK, so just quick anatomy. You just have these two really bright lights shining through these, they're basically Mandarin orange cans. but they have the nice property of causing a uniform field, because you fold over the Gaussian of the spotlight and you get a uniform field onto the diffuser, and then you have the transparencies, and these are the ARV1 optics that were used in the original NASA VR systems. Pretty cool, but hard to get these days. And then we just we prepare two transparencies. Now, even if you used a single transparency, you could get close to 3 orders of magnitude if the film recorder permitted it, but none of the film recorders are that good, at least none of the ones I have access to. So what I did instead is I have these 2 layers, a black and white layer and a color layer, but if you had them at the same resolution, you'd have all sorts of registration and parallax problems. So we use different resolutions in the different layers to avoid that. And then the LEAP optics have this nice wide perspective, and then has to be a correction for chromatic aberration. So here's the scaling layer. It's just a black and white, very low resolution layer. And then we have the detail layer, which undoes the loss of resolution by having enhanced contrast. So when you combine the two, you get back the original. So how does this work? You have the scaling layer. This is blurred version of the original. It's actually a blurred version of the square root of the original. Then you have the detail layer, which compensates for that to get back the desired output.
Was there a dark halo around the sun?
There was, which I'm going to talk about here. What happens when you exceed the limits of your detail layer? What happens is you can't quite reproduce it. What you get instead is this sort of bloom around the bright spot. But luckily for us, the eye also has problems with lens flare, and you get a scattering of light in your eye that almost perfectly masks that bit of inconsistency. So you really can't see it.
Also get some ringing around the edges.
Well, I use a Gaussian kernel, so the ringing is pretty minimal, and it's such a wide kernel that it really doesn't show. So Brightside has had a couple of prototype displays. Their early version uses DLP to create the backlight. Actually, their earliest version tried to match resolutions front to back, and that's where I said, well, that doesn't work, does it? Let's do it this way. So this is their early version, which they showed at Emerging Technologies at SIGGRAPH like 3 years ago, something like that. And it looks pretty cool, actually. It has an LCD panel here and then a DLP projector in the back, but it's this long. So it's not very practical. So they came up with an LED-based version that generates the low resolution backlight on a hex grid, and then has an LCD in front of that. And I keep thinking I'm skipping slides because it's jumping around. Oh, so what kind of color gamut do we get out of this? So this is a standard sRGB gamut represented in a perceptual space. So we've used UV color coordinates, and then we've tried to map the luminance to a TVI, using a TVI function to get a rough idea of what the true volume is, but you have to ignore side to side relative to the top to bottom because you can't really relate luminance and color very easily. But what you see with the HDR volume is that it covers roughly the same color area, but because it spans such a greater luminance range, you can maintain these saturated colors to much higher levels. So it also gives you additional apparent color. So this is what what they were calling the production unit looked like, and they produced a couple dozen of these, but they were never really. They were more like beta units. Still look nice though. The other advantage of using LEDs is that you can replace the white LEDs with RGB LEDs and get a much wider gamut. So this is something that's also in the works. So here's what you get. Here's the sRGB gamut, and if you use red, green, and blue LEDs instead of the white phosphor LEDs, you can reach out to a much wider range of colors. we're sort of waiting for the stability of the LEDs to improve, though. So that's it. Be happy to take any questions, and I have a demo over here, which I'll show in just a minute.
Have you, using more than one camera and remote control to do the shutter release?
Turn your mic back on.
Yeah, just
Get the podium down.
okay. We switch mics. So, yeah. He asked if I thought about using multiple cameras and using a single shutter release to capture different exposures at the same moment. You would have parallax problems with that, and of course the expense of multiple cameras. So I guess I'd say I thought about it, but didn't really think seriously.
Yeah, we did 3D.
Yeah, 3D HDR, that'd be cool.
Have you done any work on spatially varying tone mask rendering?
I haven't myself. I mean, I have, but only using really crude algorithms that look terrible. I haven't actually implemented any nice ones. But yeah, I think it's a good approach, and I know I've used the bilateral filter. I should correct myself. I've done a poor implementation of that, and even a poor implementation of that looked pretty good. But I haven't used it. In Photosphere, it takes too long. It simply takes too long. You don't want to wait that long for tone mapping. Yeah.
And then we're combining images, again, with the polarization filters are different, with different access to polarization.
And so taking images with different axes of polarization to what ends?
To mitigate reflections.
Ah, so like identifying specular reflections using two polarizers. I have played with that for the purposes of reflectance measurement, but I've never thought about using it for dynamic range reduction. That's an interesting suggestion.
Better color saturation.
True. The actual reduction of dynamic range isn't that great because unless you were at whatever it is, Brewster's angle, you would still get a fair percentage of the light coming through.
Couple things, getting the estimation of the lights that's scattered.
Yeah, that's a really good point. If you used polarization in that way, you could actually estimate the haze and subtract the haze, and that would be a really nice thing to do, because a lot of images that you take outdoors, your brain sort of does this haze subtraction for you, and then you take the photo and you say, oh, this looks terrible, what happened? And it's because of that haze. So by using different polarization, I mean, you can choose a polarization that reduces the haze, but you never can find one that eliminates it. So that's a good suggestion. Take two polarizations, then you have 2 points on a line, and you can actually maybe eliminate it. So
Still in a mechanical system.
yeah, but maybe you could use the two-camera approach in that case, or two sensors. Interesting idea.
You know, look through a beam splitter and not have parallax problems because a lot of RGB cameras work that way.
Yeah, and that actually has been looked into for video as a way to capture high dynamic range video, is to either use a prism with different neutral density filters or take advantage of the existing beam splitters that are in the 3 CCD cameras and just change the filters so you have instead different exposures. Yeah. There?
It would seem you could also dither the exposure by putting a mask, a neutral density mask on the sensor.
Yeah, in fact, Sri Nair and his group have done exactly that. They have a couple of papers. If you go to the Columbia's research, if you can just Google him, and they have a few papers on what they call assorted pixels, where in addition to changing color on the Bayer pattern, they change neutral, they change the amount of light that gets through, and then they have more intelligent ways to reconstruct the image based on that.
Okay, thanks again.
Thank you. Yeah.